Hi, in this video we'll learn about ROS2 launch files and its importance. We'll also try out some launch files. Here on the right hand side we have the ROS2 commands which we'll use in the video. If you already know ROS1, then on the left hand side you can find the corresponding ROS1 commands. Launch file is very important, especially when you want to run many nodes simultaneously. In ROS2, launch files are written in Python. So let's download some of the launch files. Here, just go to GitHub, then search ROS2 basics. And here, select this one, ROS tutorial, ROS2 basics. And just download this. Now go to that folder and unzip it. And here go to this launch folder and just copy these three files and paste it in the home folder. Now just minimize it and I will open Terminator and split the screen into some parts. So we'll launch this first file, turtlesim2turtle.py. So just type ROS2, we'll go for the help first. So just type ROS2 -launch then -h. And you can observe that in the usage, we have to type ROS2 launch then package name, or we can directly launch the file, launch file name. So we'll try this one, ROS2 launch and then the launch file name, so which is turtlesim2turtle.py. Because it's in the home folder, so we can directly write its name, this file. Just press enter, and here you can observe that now we have two TurtleSim GUI running. Now let's explore this launch file to get more idea about it. So just open this. Here, the first two lines, the import statement, pulls in some Python launch modules. Next is the launch description itself. So we have this function and then the launch description. Then we have the nodes. So we have two nodes. In the node, we have to specify specified the package namespace, executable name. So the package is TurtleSim. Then namespace we have given TurtleSim1 for the first node. Then the executable name TurtleSim node, and then the node name is node1. So we have given namespace because we have to launch this two TurtleSim executable. Then just type ROS2 topic list, and here you can find we have this namespace for both the turtle. So earlier we had this turtle1 cmd well. Now we have this namespace in front of it for both the turtle. Next, type ROS2 interface proto and then geometry message, then twist. We'll open a new file, empty file, and copy this output and paste it here. and then change this linear x value to 2 and angular z value to 2. Just copy this. Next, keep those GUI always on top. And then we'll publish the message on the command velocity topic. So just type ROS2 topic, then pub, then -r, and then 1. So we'll publish it at a constant rate of 1 Hz. And then the topic name. Here the topic name is TurtleSim1, then Turtle1 CMD-well. Then the message type, which is geometry message, just press double tap, and then the value. So we have already copied the value in the text editor. So just open the text editor and copy it. And paste it here. Now press enter, and here you can observe that the first turtle is moving in a circle. Next, just press Ctrl C, and similarly we will move the second turtle. So this time we'll keep linear x to 3, angular z to 2, and we have to change that namespace, the topic name. So here it will be TurtleSim2. Just press enter, and here you can observe that the second turtle is moving with the bigger circle because we have changed the linear velocity from 2 to 3, keeping the angular velocity same. We just press Ctrl C. Now here press Ctrl C, and we'll launch the second launch file, and its name is TurtleSim2 turtle with parameters.py. So just type the launch file name and enter. Now here you can observe that the first turtle background is blue, and in the second GUI you can find that the background is black. Let's open that launch file. Now here you can observe that it's because in the second node we passed the parameter, this RGB values. So you can also pass the parameters in the launch file. You can also remap the argument in the launch file. For example, TurtleSim node subscribe to this Turtle1 CMD-well topic. And if you remap the topic to, let's say, XYZ, then the TurtleSim node will subscribe to the XYZ topic. So we'll launch this third launch file, and you will get an idea how the remapping works. Just keep it always on top. And then we will publish on the first turtle. So now you can see the first turtle is moving and the second turtle is mimicking it. Now we'll learn how it's working. So here we have actually remapped the argument in the launch file. So we'll just open the launch file, open this third launch file, and we have launched this third node, which is mimic. So earlier we didn't use this mimic node, but now we are using it. This mimic node takes the input pose of one turtle and then publishes the linear and angular velocity part of a turtle to cmd-val topic of another turtle. So here you can find we have remapped the input pose to turtle sim1 pose, and then the output cmd-val to turtle sim2 turtle1 cmd-val. So here we have launched this mimic node as well as we have done remapping. So that's it for this tutorial. I hope you like this video and learned something new. If you like this video, please give us a like and subscribe to our channel and keep learning.